On the same sheet 1, we're now on question 12. Question 12. Okay, question 12 reads, solve for x and y. Solve for x and y. Given that a, x plus iy multiplied by 4i is equal to 8. Now, just to remind you, if z1 is equal to z2, we say that z1 is equal to a plus bi, z2 is equal to x plus yi, then z1 is equal to z2 if and only if a is equal to x, b is equal to y. So in this case, you are solving for x and y. So you just divide the 4i, divide 4i, then we'll get x plus iy is equal to 2 over i. Then you conjugate the right. So you multiply by negative I, you multiply by negative I. So you get x plus iy is equal to negative 2i over I times I is negative 1. Negative 1 times negative, you get positive 1. So the whole thing is giving us x plus iy is equal to negative 2i. This means that x is equal to 0 and y is equal to negative 2. So x is 0 because there is no part on the right which does not have I. And then y is 2. Y is negative 2 because the coefficient of I on the left must equal the coefficient of I on the right. B, 1 over x plus iy plus 1 over 1 plus 3i is equal to 1. You're solving for x and y. So you take this whole thing, we take it the other side. So we have 1 over x plus iy. The last part you just equate. This part must be equal to the part here that does not have I. So that y should be equal to the part that has I. The part that does not have I, you can't see it, so it is 0. The part that has I, we're able to see it, so it's negative 2. So y is equal to negative 2, x is 0. So for B, we take the other part, we take this guy on the other side. So it will be minus 1 over 1 plus 3i. And then we have 1 over x plus iy is equal to, common denominator is 1 plus 3i. And then we get 1 in 1 plus 3i multiplied by 1 on top. So we have 1 plus 3i minus 1. How do you break down 8 over 4i? 4 in here 1, 4 in here too. So it becomes 2 over I. Then you conjugate I. So you multiply by negative I, multiply by negative I. So you get negative 2I over positive I. Okay, so this one is giving us 1 over x plus iy is equal to 1 minus 1, 0. So we remain with 3I over 1 plus 3I. Okay. So we have this. Now remember we are solving for x and y. So here you just reciprocate both sides. So where we have 1 over x plus iy, we now have x plus iy over 1. So we flip both on the left and on the right. So on the right we'll have 1 plus 3I over 3I. It's the same as you cross multiply and you divide. So we now have x plus iy is equal to, we conjugate, multiplied by negative 3I multiplied by negative 3I. So get x plus iy is equal to negative 3I plus 9 over 9. Look, this step here, if you have a over b is equal to 3 over 4. If you cross multiply, we get 4a is equal to 3b. So if you are solving for b, you divide by 3, you divide by 3, and get b is equal to 4a over 3. This is the same as this. If they tell me to solve for b, I can flip. I reciprocate both sides, so I'll have b over a. Then also on the right, I should have 4 over 3. Then multiply throughout by a, so that I remain with b. So I'll have 4a over 3. This and this are the same. The question is asking us to find x plus iy. So if it's in the denominator, we can push it in the numerator for as long as we change also on the right. So that this one now becomes x plus iy is equal to negative 3I over 9 plus 9 over 9, which is 1 minus 1 over 3I. Therefore, x is 1, y is negative 1 over 3. The real part equal to real part, imaginary part equal to imaginary part. Then a task, you solve question 12C. We want to see in the group who is going to get this one. So hint, get two equations and solve them simultaneously. That is the hint there. This one is nice, so we need to do it. No extras. We got question 13. We are now dealing with rationals, with irrationals. So you rationalize. Question says rationalize the denominator of each of the following. So rationalize the denominator. The explanation on A and B. The key thing is that two complex numbers are equal if and only if their real parts are equal, the imaginary parts are equal. That is the key thing. Two numbers, Z1 and Z2, will be equal if the part that do not have I is equal to the part that do not have I this side. If the coefficient of I is equal to the coefficient of I this side, then we say Z1 is equal to Z2. Question 1, you have x plus iy multiplied by 4i is equal to 8. If you divide by 4i, you get 2 over I. Then you conjugate so that I should move from the denominator. You have x plus iy is equal to negative 2i. So we are saying this left number can only be equal to this right number if and only if x becomes 0, y becomes negative 2. So that you have 0 minus 2i, which is x plus iy. That is the only one. For b, you have 1 over x plus iy plus 1 over 1 plus 3i is equal to 1. Find x and y. This part do not have x and y, so we take it the other side. We have this. Work it out as a fraction until you get here. Don't rush to conjugate. You are solving for x and y, and yet they are in the denominator here. So what do? You switch. Make this guy the denominator. So I've made the denominator. Make the numerator the denominator now 1. To avoid changing anything, whatever you do on the left, you do on the right. On the right also, make 1 plus 3i the numerator and 3i the denominator. Then you now rationalize. You now conjugate. So multiply this guy by negative 3i, multiply the top by negative 3i. 1 times negative 3i, get negative 3i. 3 times 3, we have 9. I times I, we have negative 1. Negative 1 times negative, we have plus. Over negative times negative, plus. Negative. Negative times negative, plus. Then 3 times 3, 9. When you split this, you have negative 3 over 9, which is negative 1 over 3. 9 over 9, which is 1. This is a complex number. This is a complex number on the left. This can only be equal to this if x is equal to 1 and if y is equal to negative 1 over 3. So we have x is 1, y is negative 1 over 3. That's how the two become equal there. Okay. And now on question 13, rationalize. Switching the denominators is just helping you to avoid cross multiplications. When we said switch, we had 1 over x plus iy is equal to 3i over 1 plus 3i. Then, since you're looking for x plus iy, you cross multiply. So you have 3i multiplied by x plus iy, which is equal to 1 multiplied by 1 plus 3i. Since you're looking for x and y, you divide by 3i, you divide by 3i. So you have x plus iy is equal to 1 plus 3i over 3i. What we've done here is the same as switching. Okay. A 2 root 3 minus root 2 over 4 root 3. This is equal to 2 root 3 minus root 2 multiplied by negative 4 root 3 over 4 root 3 multiplied by negative 4 root 3. We want to get rid of the root, so we rationalize. So I'm using negative derivative here because that's what we know. So to avoid starting having variety, say, no, when it is like this, use this. So we say we'll be using the same thing. When you say rationalize, you multiply the root by a negative. You just change the sign of the root. So we'll have 2 times negative 4. We get negative 8. Root 3 times root 3. We get positive 3. Negative times negative, we'll have plus 4. Root 2 times root 3, we get root 6 over 4 times negative 4, negative 16. Root 3 times root 3, positive 3. If we factor out 4 from top, we'll remain with negative 4 by 3 plus root 6 over, negative 2 here. I'm just dividing by 2. So 4 into 8, we get negative 2. The 3 will remain there. 4 into 4, we get 1. So we have root 6. And then we keep negative 16 over 3. So that this 4 can go in here 4 times. Then you have negative 2 times 3, negative 6, plus root 6 over negative 4, negative 4 times 3, that's negative 12. So that we get negative 6 over negative 12 plus root 6 over negative 12, which is equal to positive 1 over 2 minus root 6 over 12. To rationalize is to make sure that you don't have the root in the denominator. So we say rationalize the denominator. We had so many examples, I remember. That's why here I'm going to be fast. If you have x over x plus root y, to rationalize this one, all you need is to multiply the down part by x minus root y. You come here and have x plus root y multiplied by x minus root y. So you get x times x, you get x squared minus x root y over x times x, x squared minus x root y, then it will be plus x root y, and then minus y. Then you get x squared minus x root y over this plus this one, you get 0. So we have x squared minus y. To separate these, you say x squared over the whole x squared minus y minus x root y over the whole x squared minus y. You don't divide the x squared there, because down we have a difference of two numbers. So no shortcut. C, we have 2 root 7 plus root 3 over 3 root 7 minus root 3. So we just multiply this by 3 root 7 plus root 3. And do the same on top. 3 root 7 plus root 3. Then you have 2 times 3, 6. Root 7 times root 7, 7. Plus 2 root 7 times 3. And then plus 3 root 3 times 7. And then plus 3 root 3 times root 3. Over 3 times 3, we get 9. Root 7 times root 7, we get 7. Then 3 times root 3, we have plus 3 root 3 by 7 minus 3 root 3 by 7. And then root 3 times root 3, we get 3. Binary returns positive, we have minus. So this part minus this part, we get 0. Then on top, 6 times 7, we get 42. 42 plus 3, we have 45. Then 2 plus 3, we get 5. Then 7 times 3, we get 21. Over 9 times 7, we get 63. 63 minus 3, we get 60. So we have 45 over 60 plus 5 over 60 root 21. 15 in 45, 3. 15 in 60, 4. 5 there goes 1. 5 in 60 goes 12 times root 21. So I've expressed as if we have rationalized normal root in the denominator. That's what it means to rationalize. So just take your time there when doing this work. It's not complicated, just needs your seriousness there when you're calculating, so don't make mistakes. And then you also take your time. Okay. We go to question 14. Question 14 says, let S x1 x2 all the way up to x 1000 be the heights of students taking Math 1120 in 2022 academic year. Yeah, that's the best one. You can always take it to be negative. The conjugate is always the opposite side of the other one. Okay. Assuming that there are 1,000 students taking math 1120, let star be an operation defined on S for every two heights, A, B in S. Then you define star as A star B is equal to the minimum of A and B. When you say minimum of A and B, suppose you have 2 star 7. The minimum of 2 and 7 is 2. What do you mean by minimum is the smallest? The smallest between 2 and 7 is what you call a minimum. So if you have A star B will always be equal to the smallest number. That's what this question is saying. Where these A and B are the heights of the 1,000 students. So if this person is 2 meters, the other one is 1.4 meters, the other one is 1 meter, the other one is 0.5 meters. Then if I pick 2 star 0.5, the answer will be 0.5 because that's the smallest. If I pick 1.4 star 2, the answer will be 1.4 because that's the smallest. If I pick 1.4 star 0.5, the answer will be 0.5 because that's the smallest. That's what minimum is telling us. Then, if A and B are coming from the set A, I will say that star is a binary operation on A if when I do A star B, I'll get a number C where this number C is in A. Because A is coming from A, B is coming from A, whatever I do to A and B, the answer, this answer here, must be in A. Then I'll say star is binary. When we say, is this star binary? We mean when you get A and B from this set and compute them using star, is the value that you get also in A? If the value you get is in A, then you say star is binary. If the value you get is not in A, then star is not binary in A. So in this case of S, all the highest you get will be for the students. And so every two heights, there will be, if they are equal, then you have two solutions. Minimum there is A and B. Meaning, when you say A and B, you're just picking one because they are equal. If I have 1 star 1, the minimum is 1 because they are equal. Okay? So if you pick two heights of students who are equal, then your answer is just one of them there. If I pick two students, one is taller than the other, the answer, when I do this student's height, the other student's height, the answer will be the height for the short one. That is the minimum. So we go to part 1. So in part 1, they need to help us understand. Is star binary on S? Okay, so A is coming from S, B is coming from S, where A and B are heights of the students that are 1,000. Suppose these heights, so if x1 is 2 meters, x2 is 1.4, x3 is 1.6, x5 is 1.2, x6 is 1.1. All those are heights of the students. If you pick two heights, you would have picked the two heights of the students. Now, A will be height, B will be height. And the answer must be the minimum of the two. The shorter one is the answer. If A is 1, B is 2, the answer will be 1. If A is 3, B is 4, the answer will be 3. If A is 1.6, B is 0.9, the answer will be 0.9. So for any two heights, the answer will be also a height. So we are saying whatever we do to A star, to A and B, this guy will be in S. So star is binary on R. So what you're saying there is that every time you get two heights, one of the heights there will be a solution. And those heights you're getting are for students. So then you're always getting A star B to be a number from S, where these numbers in S are just the heights. Part 2 is star commutative. To be commutative, A star B should be equal to B star A. Then you say star is commutative. Now look at this. 1 star 4 is equal to 1. 4 star 1 is equal to 1. Since you are saying that every time you get two numbers, the shorter one is your solution. Every time you get two numbers, the shorter one is your solution. So then this means that A star B will always be equal to B star A. According to the definition of A star B, the minimum of A and B. So star is commutative. Part 1 is just asking you to check if every time you get two heights, the answer will also be a height. Because A is a height, B is a height. Star is just asking you to pick this, the shorter one, the minimum height of the two. If I have my heights 1 and 2, then 1 is the answer there. That's what star is looking. If I have my heights 3 and 4, star is looking for the shorter one, 3. 1.6 star 0.9, star is looking for 0.9. And since I've gotten the height, 0.9 is the height. So every time I pick two heights, my answer will be height. Now, because my answer is the height coming from S, then star becomes binary. That's what it means, not on R, I mean on S. That's how easy and nice it becomes there. Then C. So this was B, I mean, A. Then C. Compute Evaluate 1.3 meters star 1.5 meters star 1.8 meters. So you start with the brackets. So what is 1.3 meters star 1.5 meters? The smaller one, 1.3. So it means that this whole thing here is the same as 1.3. Then star 1.8. Again, the smaller one, 1.3. That's all. Every time I have two numbers, star is looking for the smaller number. That's our minimum. Every time you have two numbers, star wants a smaller one. So if I have 1 star 3, star 1, if I have 1.3, star 1.5, then the answer is 1.3. Then from there, I'll have 1.3 star 1.8. Then the answer is 1.3. The smaller one. That's what this question was asking you to do.